Hello friends. So today we are going to solve once again 3 questions, and these 3 questions are related with the projectile motion. One second. Okay. So in the first question, we are given that a ball is thrown from ground level with initial speed v. Determine the angle of projection theta naught for which the ball travels the distance through the air is maximum. Okay. So basically it means that if this is the level ground and the projectile is projected from point A, and this is the path taken by the projectile, and it meets at point B, and in the question it is given that its velocity is our v at angle of our theta. Okay. So we have to you can say find out this theta such that the distance traveled through the air, it means this curved path is of maximum. Okay, so this distance has to be, the curved path has to be maximum. Okay, so this is the question. Okay, so we are going to start with our equation of the motion. So we can say the equation of motion and for our x of t we can write will be equal to our v cos of theta multiplied by time t, that is a horizontal distance traveled, and in y direction we can write this as y of t is equal to our v sine theta times t minus 1 by 2 g t square. Okay, and from here it starts from point A and reaches point B, and the time taken, or we can say time of flight, if represented as TF, therefore we can say that for time of flight is equal to TF. Okay. And for this time of flight TF, that is from point A to point B, this value of y should be equal to 0. Okay. Because ultimately it is going to start from A and once again reach at the same level, so value of y is equal to 0. And if we solve it from here, we can get that our TF will be equal to, this will be coming as 2v sine of theta and divided by g. So this is the total time of the flight, and we are supposed to find out our distance traveled through the air, that is basically our arc length. We can say distance traveled through air. Which is nothing but our arc length. And we can easily find out that the arc length of the trajectory, you can say that arc length of trajectory, let us suppose that is given as s, and then s will be equal to our integral of our velocity that is dependent upon time, and we can take its modulus, okay, to avoid our derivative of t, and we can integrate it from 0 to tf. Now we are going to find out this v of t, and v of t will be equal to our the x component square plus y component square and its square root, basically its magnitude. And we can say that our x component will be equal to v cos of theta, and our y component, and we have to remember this y component is with respect to the arc, not basically the vertical component. Okay, so these two components are with respect to the arc, and we know that velocity in x direction is always constant throughout the arc length. Only the velocity in y direction is going to change, and that changes also. So we can say that v of y will be equal to over v sine of theta minus gt. Okay, this is our with respect to our how the velocity is going to vary from our arc. Okay, and therefore we can say our magnitude v will be equal to vx square plus vy square. So this comes as v cos of theta whole square plus v sine of theta minus gt and whole square and its square root. And now we can easily substitute it in our integral equation. Therefore we can say that our s is equal to 0 to tf, and this comes as a v square cos square theta plus v sine of theta minus gt whole square, and this is our derivative of t. And therefore we can write that we are just going to simplify the integral, okay, and we can take, okay, let me open, square root is missing. So let me open the integral, the square root, and we can take as outside the bracket our square root. So we can this as v, this comes as 0 to tf, and we have our cos square theta plus one second, let me keep this v square inside, later on we can solve it. So this is v square, and we have this will be v square sine square theta plus g square t square and minus twice v gt sine of theta, and this whole will be under the square root derivative of t. And these two, if we take v square, this will be cos square plus sine square, which is equal to 1. And now let us take v as common, so we can write this as our v integral 0 to tf, cos square plus sine square will be equal to 1, so this comes plus 1, and we are having this as plus g square t square upon v, and v, this will be v square and minus 2 gt upon v, and we have this as sine of theta, and its square root. Okay. So we have to solve this now. Okay, so therefore let us assume that our u is our v sine of theta minus gt. Therefore you can say that our du will be equal to our one second. Yeah. And this will become as minus of g derivative of t. And let us redefine rather the limits. So whenever t was equal to 0, we get our u is equal to v sine of theta. When t is equal to our tf, we get our u is equal to minus v sine of theta. Okay, and now we can easily substitute and get the answer. So we get our s is equal to, and dt will be equal to du by g. So we can write this as v upon g, and integral minus v sine of theta, and this will be v sine of theta, and we get this as a v square cos square theta plus u square, and this is our du. Okay, now it is easy to solve. We are going to use the general formula of our integral a square plus u square du. This gives us 1 by 2, and we have u a square plus u square plus a square and natural log of our u plus a square plus u square and square root. Therefore we can write that our s will be equal to, we get this as u square upon g, and we have our sine of theta plus cos square theta natural log of 1 plus sine of theta divided by cos of theta. And so we have to basically maximize this s, that's arc length. So we are only going to consider this integral, this trigonometric equation. And for that, let us assume a function f of theta which is equal to our sine of theta plus cos square theta and natural log of our a. Here we have assumed that our a is equal to 1 plus sine of theta and cos of theta, and we are going to derivate it, and this we can say that our df by d theta sine of theta is going to give us cos of theta plus we have our cos square theta natural log of a, so cos square theta we can use here uv, so we get this as cos square theta derivative, and that will be equal to minus 2 cos of theta sine of theta natural log of our a plus, now cos square as it is, we are going to our derivate natural log of a, and that will be giving us cos cube theta divided by 1 plus sine of theta plus cos theta and sine theta. Okay, so finally we can take out this cos of theta as common here, here as well as here. So we can say that our df by d theta will be equal to cos of theta 1 minus 2 sine of theta natural log of a plus cos square theta upon 1 plus sine of theta plus sine of theta. And we can simplify this function, and cos square we can write 1 minus sine square theta, and we can say that our cos square theta 1 plus sine of theta, so this comes as 1 minus sine square theta and 1 plus sine of theta. Numerator comes as 1 minus sine theta 1 plus sine theta divided by 1 minus, this cancels out, so this comes as 1 minus sine of theta. And now we can just substitute it inside the bracket, and we get this as our cos of theta 1 minus 2 sine of theta natural log of our a plus 1 minus sine of theta plus sine of theta, and this sine theta cancels out, and this 1 plus 1 becomes 2. Therefore we get that our cos of theta, and we can take 2 as common, so this comes as 1 minus sine of theta natural log of our a. So this is our derivative, and for maximum we know it has to be equal to 0. Okay. And cos theta is equal to 0, so it means that theta will be our pi by 2. Okay, so it means simple vertical launch, which is non-trivial. Okay. Therefore we can say that 1 minus sine of theta natural log of a is equal to 0, and from here we can write that 1 is equal to our sine of theta, natural log of, now we can substitute value of our a, and from a we get this as 1 plus sine of theta, and we have this as our cos of theta. Okay. And this was our for the maximum, you can say, equation such that theta is our maximum. And if you want to find out the exact value of theta, so this theta will be approximately coming as 56.5 degrees. So for this value of theta, the arc length will be maximum. So this was our first question, and now we come to our second question. Second question states that a ball is projected with a speed v from the edge of a cliff at a of height h. The ground below of the cliff is horizontal. Determine the angle of projection for which the ball covers the maximum horizontal distance and find its maximum distance. So in this case, we are given that we have a cliff, and at the bottom of the cliff there is a horizontal path, and from the cliff we project a with projectile, and with the speed of, and with angle is our theta, and its projection velocity is given as v. Okay. So this projectile is going to follow the path, and it will be going something like this here. Okay. And we are given that h is the height of the cliff. Okay. And let us assume that this bottom of the cliff is our origin, so this comes up 0, 0, and so we can say that the top of the cliff will be having a coordinate of 0, h. Okay. So initially we can say that we can write our initial condition and under initial condition our x at time t is equal to 0 is at 0, and the y at t is equal to 0 is at a height of h. Okay. So this is our initial condition, and we can define the velocity components. Velocity components, and first is our v of x, which will be equal to our v cos of theta, and our second is our v of y, which is equal to v sine of theta. Now we can write the equation of our motion. Equation of motion, and for this equation of the motion we can say that our x of t will be equal to our v cos of theta multiplied by time t, and our y of t will be equal to our h plus v sine of theta, sine of theta times t and half gt square. Now we can find out the time of flight when the ball hits the ground. Okay. We can say when ball hits the ground. And when ball hits the ground, we know that value of y will be equal to our 0. And therefore, we can write that our h plus v sine of theta times t minus half g t square is equal to 0. And we can rearrange it in the quadratic form for t. So we can say that our half g t square minus v sine theta t minus h is equal to 0. And this is quadratic. From here we can find out our value of t. So we can say that the value of t will be equal to our, this will be v sine of our, we are only going to take the positive value, so v sine of theta plus, and we have a b square, that is v square sine square of theta minus 2gh, so this comes as minus 4ac, 4 is about 2, so this comes as 2gh and its square root, and 2g, or we can say 2a, that will be g. Okay, that is our basic quadratic formula. Therefore, we can say that our horizontal distance traveled which is suppose our d, and this d will be equal to our x when the time of flight is represented as our tf. Okay. So we can say that our d will be equal to our v cos of theta multiplied by our t, and we already know value of t, so we substitute it, we get our d is equal to v square upon g, and cos of theta, and we have this as sine of theta plus sine square theta plus 2gh upon v square and its square root. Okay. And for the sake of simplicity, let us assume that this function is equal to our beta, okay, because this is basically constant, so we have to find out, differentiate with respect to theta, so it doesn't matter. Therefore, we can say that our d is equal to v square upon g cos of theta, and we get this as our sine of theta plus sine square theta plus beta and its square root. And we have to maximize with respect to theta, so we are only interested in this trigonometric function. So let us assume that our f of theta is equal to our cos of theta sine of theta plus sine square theta plus beta and its square root. And now we are going to derivate it, so we get that our tf upon d theta, and cos is going to give us minus of sine theta, and the other function is going to as it is, so this comes as sine of theta plus sine square theta plus beta and its square root, and that will be plus, we have cos of theta, and this sine is going to give us cos of theta plus, and this will be our, the denominator, sine square theta plus beta square root, and we get this as our 2 sine theta cos theta, 2 and 2 half, so this comes as sine theta and cos theta. And we are going to further solve it by, okay, we can just multiply, this will be over sine square and this will be cos square, and we can combine them. So we get this as our cos square minus sine square, cos square theta minus sine square theta, and we multiply it by the denominator, okay, and 1 second, sine square beta, and okay, so this comes over sine square theta plus beta, and if we equate equal to 0, because this has to be equal to 0, and therefore we get this as our this will be our sine theta and beta minus, yeah, so this comes as our sine of theta, and we have a beta minus cos square theta minus sine square theta. And so we can square it and then we solve it. Okay. One second. This combines sine square theta and beta, so this comes, okay, yeah, this looks good. And the solution, so it is a little bit lengthy, so I'm going to directly provide the solution for it, and we get that our sine of theta for maximum will be equal to 1 upon 2 plus beta and its square root, where we know that our beta is equal to over 2gh upon v square. Therefore, we get that our sine of theta maximum is equal to 2 plus 2gh v square and its square root. So this is the maximum value of our theta. And we are also interested in finding out the maximum horizontal distance. You can say maximum horizontal distance, and for that we already know our sine of theta, and we are going to substitute this sine of theta in the equation of our this equation. Okay, let us call this equation number 1. So this will be giving us maximum value of our this d max basically. So we can say that from equation 1, our d is equal to v square by g cos of theta, and this is our sine theta plus sine square plus sine square theta plus beta and its square root. Okay. And we already know our sine of theta. From here we can find out our cos of theta. So we can say that our sine square theta is equal to 1 upon 2 plus beta, and we require our cos of theta. Cos of theta will be equal to square root of cos square theta, which can be written as 1 minus sine square theta and its square root. And we substitute value of this sine square. So this comes 1 minus 1 upon 2 plus beta and its square root. So this will be equal to 2 plus beta, and this will be equal to 2, and we get here 1 plus beta. One plus beta and its square root. And we substitute in this equation. Okay, so we are only going to concentrate on this part. Later on we can multiply by v square by g. So we get cos of theta. Cos of theta is 1 plus beta square root divided by square root of 2 plus beta. And inside we have sine of beta, and sine of beta is 1 upon square root 2 plus beta, plus we have sine square theta. Sine square theta is our 1 upon 2 plus beta and its square root. This can be further written as 1 plus beta, its square root, 2 plus beta. This comes as 2 plus beta and its square root, plus we can write this as our square root 2 plus beta, and we get this as 1 plus 2 beta plus beta square and its square root. And so we get this as 1 plus beta square root divided by 2 plus beta square root, 1 plus 2 plus beta and its square root. And this is our beta plus 1 whole square its square root divided by 2 plus beta its square root. And this cancels out, and we multiply inside by this our square root. Or let us take LCM first, then we are going to multiply it. And therefore we get this as 1 plus beta square root 2 plus beta square root. Denominator will be our same 2 plus beta, and numerator we are going to get this as our 2 plus beta. Now we are going to multiply it. Okay, and so we get this as 1 plus beta square root multiplied by 2 plus beta. Denominator a will be equal to our 2 plus beta, which cancels out. So this comes 1 plus beta and square root. So this was a little bit lengthy, and therefore we can say that our d max is equal to our v square upon g and 1 plus beta whole square. And we can substitute value of beta, so we get v square upon g, 1 plus, and beta is our 2gh upon v square. So this is the maximum value of the distance, and we already found out the maximum value of our angle. And these two relationships we are going to use in the next question also. So this question states that a ball is released from rest from the height h. It strikes an inclined surface at a height y and rebounds without any loss of speed. The surface is inclined such that the ball leaves it at an angle theta with the horizontal. Determine the value of y and theta for which the ball covers the maximum horizontal distance. This is same question as the second one, but only difference is that in this case the ball is dropped. In the second question the ball was projected as a projectile. So this is the major difference between the two, but the basic formula is going to remain same. Okay. So we have inclined plane, and the ball, let us suppose, strikes at this particular point, and this height is given to us as a y. Okay, and it is dropped from height h, and after it strikes this point it behaves like a projectile and moves in this direction. Okay, and the angle is our theta. Okay, so this is the basic question, and we have to find out the value of y and theta for which the ball covers the maximum horizontal distance. Okay. So let us assume that we have to keep in mind there is no loss of speed. It means the velocity just before the striking, suppose this is point A, will be equal to the velocity after the striking. Okay, so we are going to say it has a velocity v, and it is dropped from this point B. So here entire energy will be over mgh. Okay, and at a point it will be combination of both kinetic energy as well as the potential energy, because this point A is a height of y. Therefore, you can say that initial energy at height h, initial energy at height h, let us call this EI, will be equal to over m h, and then we come to the energy at height y, energy at height y, let us call this as our E final, and this E final is the combination of our kinetic energy and our potential energy, that is mgy. Okay, so conservation of energy we can easily use, and from there we get that our conservation of energy, or we can say energy conservation, energy conservation. So we get our E initial is equal to our E final, which tells our mgh is equal to our half m v square plus mgy, and mass we can just throw out. From here we can find out our velocity v. Okay, and we can say that our velocity v will be equal to our g, we can take as common, and this will be over 2g h minus y and its square root. So indirectly this is nothing but our velocity of projection at point A. Okay, so you can say this is nothing but our velocity of projection at point A. Okay, so now this question is same as the first one. Okay, therefore we are going to use two formulas. We are going to use our d maximum, which we already derived, is our v square by g, and this 1 plus 2gy divided by v square and its square root, and we get our sine of theta will be equal to 1 upon 2 plus 2gy, and we have this as v square and square root. Now in this case we have to remember that in this particular question we have to determine for maximization of this horizontal distance, it should be with respect to y as well as our theta. Okay. And this d max in the first question we only solved it with respect to our theta. Okay, so we have to keep this in mind. Okay. And in the first part also the velocity was given as v, but here we have already calculated that velocity is governed by this particular equation. So we can modify our maximum, that is our d max is equal to, and we get this as 2g h minus y upon g, and we have this as square root 1 plus 2gy, and this is our 2g h minus y. Okay. And here we can cancel g and g, here goes, here 2g and 2g goes, and we can just solve the inside the square root. So we get this as d max will be equal to, we have this as 2 h minus y square root, this will be h minus y plus 2y, giving us, sorry, this will be h minus y plus y, which will be our h upon h minus y. And further we can just rewrite it as we multiply inside h minus y, so we get this as 2 and square root of h multiplied by h minus y. So this is our maximum distance. Okay, but this is only dependent upon y. Okay, therefore we can say that maximizing the distance with respect to y, okay, because the derivation which we used is only dependent upon our theta, because we solved it by taking derivative of theta equating to 0 and finding out d max. Therefore let us say we denote this as r of y is equal to 2 h minus y. Okay, and we know that this will be true for our y less than equal to h but greater than equal to 0. Okay, and so we can differentiate it, and for differentiation let us assume that we have our function u which is equal to h minus y. Therefore we get that our du by dy will be equal to minus of h. Therefore we can say that our dr with respect to our y will be equal to, this will be 2 1 by 2, and we get this as u, and this will be our u minus 1 by 2 and multiply by our h. So we substitute back our u, so this 2 and 2 cancels out, so we get this minus of h upon h minus y and its square root. So this is our value of our this derivative. And so we are going to make analysis of this derivative, and for that we are going to consider that for y less than and greater than 0, and our numerator obviously it is dropped from the height h, so this height h is always greater than 0. Okay. And our denominator which is our h minus y and square root is greater than 0. Okay, because our this dr by dy is a negative function. So if both are greater than 0, then only our dr by dy will be less than 0. And therefore from here we can draw a conclusion that our r of y is strictly decreasing, and but there is no interior maxima, and because of that we can say that our maxima occurs at lower boundary, which is our basic property of our maxima and minima. So lower boundary, which gives us that value of y should be equal to 0. And if you put value of y is equal to 0, and in this equation, so we get our d max. So we can say put y is equal to 0 in, let us call this equation number 2. In equation 2, we get our d max will be equal to 2 square root of h minus 0, which gives us twice h. Okay, so this is our maximum for our dependent upon our y as well as our theta. Okay, and we can find out the optimal angle rebound. Optimal rebound angle and we already know the relationship that sine of theta is equal to 1 upon 2 plus 2gy, and we have this as v square and its square root. And we have already derived that our v square is equal to 2g h minus y. So we substitute it, we get sine of theta is equal to 1 upon 2 plus, and this comes as 2gy, and 2g cancel out, so this comes as y upon h minus y and its square root. And we can just manipulate the denominator, so we get this as sine of theta is equal to 1 upon, this will become here 2h, and okay, because we have to find out maxima for the lower bound, that y is equal to 0, so this solves automatically. So this function goes away and this comes as square root of 2, which gives us a theta is equal to over 45 degree. So therefore we found out the value of theta, the maximum theta, and our maximum value of horizontal, that is our d max, and this tells us that this particular question was a combination of two parts. Okay, the first part was our question number 2. In that question we only solved this portion, and that gave us two results, and these two results were our d max as well as our sine of theta. But for this particular question, the ball is dropped from a height b to point A, and we found out value of v by using conservation of energy, and then we solved it for our maximum value. Okay. So this completes our 2 questions for, sorry, not 2 but 3 questions. So in this particular video question number 2 and 3 are interrelated. We have used the formula of question number 2 in order to further solve the question number 3. So we have to keep this in mind. Okay. Thank you.